Well, hi there. This is our main steam header, 100N 109 building. Basically, we drew it in little sections. It's just much of a mess if you put everything on the drawing. I have a main steam line here. There's another main steam over here trying to split up some of the lines and the valves. It's a real simplified drawing. We don't have any of the vents, drains, or the high pressure return lines on it. But basically the main steam header was a 46-inch header on the roof of 109 building. It was in 4 sections. It was to limit the thermal expansion. If you had one pipe, the expansion would be too much. You start getting a lot of thermal stresses on the different pipes coming off of it. It was designed for pretty much straight through operation. The steam would come through and you'd probably go out somewhere into here over to Hanford generating project. You wouldn't expect to put all the steam up here and take it out down here. The line was just too small for that. So the main steam header is more of an equalization line for all the lines coming in. It also was a manifold to hook all the different systems together. The main steam header had the 4 sections. The one with cell 6 was longer. When they added cell 6, they added to it. The equalizing header, this was kind of balanced the flow between the different sections. You had about an 18-inch line that ran underneath the mezzanine on the roof. Then there were valves that went around each section. 4B and 2A had cross ties. Their control valves would sit on this side of it, just trying to balance the flow. So it was like 1 1/4 cells went to each section. I believe this one was 2.5. It was a bigger header. The feed to it, you had your 12 steam generators. Steam generator come up here, it'd feed your steam drums. There are 2 28-inch lines that went up to the main steam header. You had your HPV 202s. The odds were the butterfly. HPV 202 evens, they were the gate block valves. This just shows cell 4A. Each of these cells here would have the same setup. So you can see this would be really, really complicated if you drew the whole thing out like it actually was. In the main steam header, the main purpose was to ship the steam over to the Hanford generating project, otherwise known as Whoops, owned it. They had 2 turbine generators. This number here refers to what turbine it went to. You'd have them alternated. So if they lost turbine, it'd still feed the other one. It'd still maintain balanced flow. This is just one of the valve stations to a number 1. All these had the same setup. You had your 6260 valve, 6261, then you had your HPV 6220 as a warm-up line. There are 8 of these across. So this part just shows the steam coming in and the main steam going out of the main steam header. On this drawing we have the main steam header again, and this one we're feeding the dump condensers. There are 16 of these that came off of the header. 30-inch line. You had your HPV 222 and HPV 201s. These were hydraulic operated. I remember the hydro packs on the mezzanine on top of the roof. Could be a problem in the winter. So these are hydraulic operated valves. These controlled the main steam header pressure. Supply system, or HGP, couldn't take enough steam. These would open and maintain the steam header. Or if you had a load rejection or a trip of one of the turbines, this would open and maintain the header pressure, keep from scramming the reactor. Normally 180 psi would scram the reactor main steam header. I believe it ran about 135 psi normally. This was saturated steam, which is pretty amazing. You could use saturated steam to accomplish this much. Your main steam header, and normally feed the inter-building header. It's this header here. You had your basically 207 valves that would put steam to inter-building header during normal running, check valves on it. This steam went over to 184 to run the turbine generator and the deaerator, also the steam jet air ejectors. So basically the inter-building header ran about the same pressure as the main steam. It could be changed. 184 building, you had your HPV 108R and 107R. This was 450-pound boiler steam coming in. These were pressure reducing station. You had 3 boilers in 84. 2 are combustion engineering, rated at 200,000 pounds each, and was a Foster Wheeler rated 575,000. So you'd run one set or the other. There's some different schemes to run it. But anyhow, your high pressure steam would come in from the boilers. Pressure would be dropped to about 125, 35, something in there. Feed inner building header. Inner building header, it couldn't go to the main steam, it was blocked, but it would feed your drive turbine header. This was set for 62 to 76 pounds. I think it ran somewhere around 65. I'm not totally sure the number, somewhere in there. 80 psi G was maximum on it. So to control pressure, you had your 6210 valves. 2 and 3 went from inner building header to your drive turbine header. 6210, 1 and 4 went from the main steam header to your drive turbine header. So there are several ways to run it. Your inner building header. It also went to a letdown station to feed the drive turbine air ejectors. They ran around 60 pounds. I think it ran a little higher than that. I was thinking somewhere around 70, but I might be wrong on that. It also provided sealing steam to the drive turbines. This went through a pressure reducing station. And it also fed the emergency seal water turbine for the primary coolant pump seals. That's not shown on this. So you had your drive turbine header. This fed all 6 drive turbines, 24-inch line. You had your HPV 235 valves. These were blocks. Number 6 had the HPV 6235. A lot of the stuff that was added was cell 6. They put a 6 in front of the numbers. This also had a backup to the hogger and drive turbine sealing steam. And I believe also the air ejectors could come off this too. So this was for startup. You'd use the inner building header, run off a boiler steam, provide steam to your drive turbines, sealing steam, run the air ejectors or the hogger off it. This would be for getting the plant up and running. And then once you hit a certain megawatt load, then you'd stop, build up steam pressure and try and get the drive turbines up to 3,600 RPM for full load. About 9% of the main steam was used in-house. They had 8 dump condensers warmed up above 650 megawatts. That was for load rejections and pressure control. It also fed the drive turbines, the 184 turbine generator, and the deaerator tank. This is just a really quick overview of the steam systems, the main steam header. If anybody has any more information or want to add to this, feel free to. It's just a quick overview. We'll probably do the inner building header 184 next. And we're going to get into the reactor here eventually. We're kind of sidestepping it. So anybody that's old reactor operators want to add to this or have any information, let us know. But we found a lot of information on this as I've been researching it. And there was a plan to run this reactor at 4,800 megawatts. I believe we'd run somewhere around 3,000, 3,300. It may have went to 3,800. That number I'm not totally sure of. I know it's rated for 4,000. First we're kind of worried about what we could actually say on this. But there's a lot of stuff on the internet, so I think none of it's really classified anymore. But anybody has any insight or ideas or want to add to this, let us know. This is kind of a project we're doing, just trying to document how the place works. So someday somebody go back and figure out how it actually worked. Have a good day.